What if I told you that a fertilizer which dissolves completely in water can increase nutrient efficiency by over 90%, reduce wastage, and boost crop yields dramatically? This technology is transforming the way we feed our planet, ensuring every drop counts. Welcome to today's deep dive video on manufacturing of NPK Water Soluble Fertilizer. I am your host for Simple GAN. In this video, you'll learn what NPK water soluble fertilizers are, the raw materials used, and the step-by-step industrial manufacturing process. We'll also dive into quality control tests, packaging and storage, and why these fertilizers are revolutionizing modern agriculture. So whether you're a chemical engineer, fertilizer plant operator, agriculture student, or entrepreneur, this video is for you. Let's get started. Sibling, what is NPK water soluble fertilizer? These are high-purity chemical fertilizers that dissolve 100% in water without residue. Unlike traditional granular fertilizers, these are designed for immediate absorption and zero waste in modern irrigation systems. First, we have nitrogen. This is the engine of plant growth, critical for the production of chlorophyll and protein. Next is phosphorus, which is essential for root development, energy transfer, and the early stages of flowering. Finally, potassium ensures fruit quality, water regulation, and provides the plant with natural disease resistance. You'll often see common grades like 19-19-19 or 20-20-20, which provide a balanced ratio for general crop health. Specialized grades like 13-40-13 or 12-61-0 are used for specific growth stages, like root establishment or blooming. These fertilizers are the lifeblood of fertigation, where nutrients are delivered directly through the water lines of a drip system. In hydroponics, they provide the entire nutrient profile, allowing plants to grow without any soil at all. They are also perfect for foliar spray, where the leaves absorb nutrients directly for a near-instant crop response. Factory overview of manufacturing process. Manufacturing these fertilizers is a precise chemical blending and crystallization process. It is fundamentally different from the granulation used for conventional fertilizers. It requires surgical precision. There are 8 major steps: raw material selection, weighing, dissolution, and reaction. Then comes crystallization, drying, milling, quality control, and finally, packaging. Let's break each step down. Test tube raw materials used. Everything starts with high-purity sources. Nitrogen typically comes from urea or ammonium nitrate. For phosphorus, we use monoammonium phosphate or MAP and monopotassium phosphate, known as MKP. Potassium is sourced from potassium nitrate or potassium sulfate. These must be low insoluble and free from heavy metals. Often, micronutrients like zinc, boron, and iron are added to create a truly complete nutrition package for specific crops. Balanced scale weighing and batching. Precise formulation is the backbone of this industry. Every gram must be accounted for. PLC-controlled batching systems ensure accuracy within a tolerance of plus or minus 0.1%. Any deviation ruins the batch. Fire dissolution and chemical reaction. The raw materials are fed into a stainless steel reactor with hot demineralized water. Agitators ensure complete dissolution, while the temperature is strictly controlled between 60 and 90 degrees Celsius. Snowflake crystallization process. After the reaction, the solution is cooled slowly. This is where the magic happens and pure NPK crystals form. The cooling rate determines the crystal size. We aim for uniform crystals to ensure better flow and faster dissolution for the farmer. Wind-face drying operation. The wet crystals are dried using a fluidized bed dryer. Final moisture must be less than 0.5%. Gear milling and sieving. Dried crystals are milled to a size of 100 to 300 microns to ensure they dissolve instantly in the field. Microscope quality control. We test for nutrient content, water solubility, and heavy metals. Compliance with ISO standards is mandatory. Packaging. Finished products are packed in moisture-proof laminated bags using automatic form-fill seal machines. They must be stored in dry conditions, away from sunlight, to prevent caking and preserve their high solubility. Globe showing Europe Africa why shift to water soluble? Because of 100% nutrient availability, zero clogging, and higher yields in precision agriculture. That's the complete industrial process. If you found this deep dive helpful, please hit that like button and share it with your engineering peers. Subscribe for more chemical and industrial process explanations. This is SimpleGAN signing off. See you in the next one.